Okay, listen. So next topic is combinational circuit design. When we go for combinational circuit design, you need to know what are the system available. So as digital system consists of two types of circuits. One is combinational logic circuits, another one is sequential logic circuits. Okay. So combinational logic circuit means output depend on the present input only. Okay. In sequential logic, output depend on the present input as well as past output. Okay. Example for combinational circuits are adder, subtractor, multiplexer, mux, demux, encoder, decoder, like that. They are depend on the present input only. If I are giving 4 and 5 means output will be 9. If I are giving 5 and 6 means output will be 11 in the adders. That means output depend on the only present input. In sequence circuit, not like that. Output depend on the present input as well as the past output. Okay, this is the concept. So in this chapter, we are going to discuss about only the combinational circuit design. First, we need to know the design procedure of combinational circuit. So first step one, analyze the given problem. First, we need to analyze study the problem. Okay, how many inputs, how many outputs, like that we need to know. Okay, then what are the application? Okay, application, what is the requirement of application, like that we need to. So we get to produce any waste programs, waste combination circuit. That application should be useful for the some events. Okay, so that is step one is analyze the given problem. Step two, determine the number of input and output variable. Step 2, determine the number of input and output variable. Step 3, assign letter symbols to input and output variable. Assign letter symbol. That means A, B, C, D, or X, Y, Z, or PQRS, like that you have to define. So derive the truth table indicating the relationship between input and output variables based on the specification of given problem. Derive the truth table indicating the relationship between input and output variables based on specifications of given problem. Next, next step will be obtain the simplified Boolean function for each output variable by using schema. So final one will be draw the logic diagram for the above simplified expression by using logic gates. That is the concept. So in this topic, we are going to discuss about adder, subtractor. So like that, we are going to explain. So half adder, say a circuit that will add two bits and produce a sum and a carry bit. Full adder, the circuit that will add three bits and produce a sum and a carry bit. So this is the half adder and full adder concept. So half adder means we are going to add two bits. Okay, full adder means we are going to add three bits. So in half adder, this is the basic block diagram. Okay, here we have two inputs and two outputs. A and B as a input, sum and carry as output. Okay, this is the truth table for half adder. If you're giving 0, 0 means sum 0, carry 0. So next to 0, 1 means sum 1, carry 0. 1, 0 means sum 1, carry 0. 1, 1 means sum 0, carry 1. Okay, then you have to define the k-map. So we have most of the students having doubt on the, sir, how many k-map I have to draw for this, sir? Okay, so that means you have to depend on the k-map, number of k-map depend on the number of output. If output is 3, you have to draw 3 output, 3 k-map. If output is 2, you have to draw 2 output. So like that you have to define. So finally you will get the two equations. Using equations you have to draw logic diagram. This is the combination half adder combinational circuit design. Same as full adder. Same as you are putting 3 inputs A, B and C in. Same 2 outputs sum and carry. Okay. Then truth table. Then came up simplification for the sum and carry. Then problem. So here we have more number of input variable for this sum. So you have to reduce the simple Boolean loss. Using simple Boolean loss we can reduce up to like this. Okay, for simplification of logic diagram, you can use like this. Then subtractor. So the half subtractor, that is we are going to subtract two number two digits. The circuit will subtract two bits and produce a borrow and a difference. So full adder subtractor, the circuit will subtract three bits and produce a borrow and a difference. So half adder, A and B input same. So output will be borrow and difference. Okay, A and B inputs, output on the difference and borrow. So 0 by 0 means 0, borrow 0. So if you have 0, 1 means different 1, borrow 1 because you cannot subtract 0 by 1. 0 minus 1. Okay, so you have to define borrow as a 1. Then 1, 1, 0, then 0, 0. So this is a logic diagram for difference and borrow. Full subtractor, same as 3 input and 2 outputs. Borrow and sum, sorry, borrow and a difference. So for this, you have to define the truth table and the K-map simplification. For K-map, you have to define for the difference as well as borrow. So then, final, you have to draw the logic diagram as per the concept B is equal to B, A plus B. That is borrow in. 4-bit binary adder. So not 4-bit binary adder, define the two numbers. For example, two binary data. So previous one, half adder, full adder, and half subtractor, full subtractor, we are deal with the bits. So individual bits we are going to add and subtract like this we are using. Here we are going to add the data. For example, 1011 and 1010 like that we are going to add. Okay, we are going to add the multiple number of bits at the time, that is parallel adder. Okay. So next to 4-bit subtractor. So for subtraction using ones complement method. Okay, here they are using the complement method. Already we know that ones complement and twos complement like this. Okay, this is the another concept using the subtractor. So next advantage of multiplexer and demultiplexer. So advantage of multiplexer and demultiplexer, that is the new next combinational circuit. So multiplexer. So it is a definition. A multiplexer is a device that allows digital information from several sources to be routed onto a single line. That is many into one, like that they are defining for transmission over the line to a common destination. So several data input lines, some select lines. So less than the number of input lines, single output lines. If there are n data, input line means m select lines. Then 2 power m is equal to n. Okay, if you are going to, if you are giving a 8 input means you have to use what? 3 select lines. So these are the concept used in the multiplexer. It is a functional diagram of a multiplexer. We are giving more number of inputs and one output. Okay. We have different type of multiplexer. 2 is to 1, 4 is to 1, 8 is to 1, 16 is to 1. So 2 is to 1 means select line. If select line is 0 means input to I0 will be in the output. If select line is equal to 1 means input 1 will be connected with the output. This is a concept. Same as 4 is to 1. So here, if inputs are, if select lines are 0, 0, output will be I0. 0, 1 means I1. 1, 0 means I2. 1, 1 means I3. Then 8 is to 1. Same concept that was used for all the multiplexers. Okay, so like this. For every input of select lines, there will be some input connected with the output. This is like the switches.